In section 25, we're looking to change bases of exponential expressions to find equivalent expressions. Activity 1 really has kind of two purposes. The first purpose is for us to become more familiar with the powers of 2 and the powers of 3, so that we can recognize later that, if I have to change something like 64, I can easily change it to a power of 2. Or if I need to change it at 81, I can easily change that to a power of 3. So these values right here, 2 to the third, 2 to the fourth, 2 to the fifth, and so on, those are really important for you to become familiar with so that you're able to quickly change bases. Same thing down here with a base of 3, 3 squared, 3 to the third, 3 to the fourth, and 3 to the fifth. And those are ones that are going to show up pretty frequently. The second purpose of the first activity is for us to get familiarity with using those exponent rules that we looked at in section 22 in a little bit different way, and using that to change some bases. So looking at the first problem here, we have 16 to the 7th. We know that 16 is 2 to the 4th power, so we can change this to 2 to the 4th. And when I take that to the 7th power, my rule there is to multiply the exponents, because it's power to a power. So multiplying 4 and 7 gives me 28, so there's my exponent. Same thing down here in number 2, we had 81 to the 8th. We can change that to 3 to the 4th to the 8th, which will become 3 to the 32nd. Now the rules are the same whether we've got variables in the exponent or just numbers in the exponent. Nothing's really different. It's just a matter of how it's going to look. So looking at number 5, we have 8 to the 5x power. 8 we can change to 2 to the third. Now 2 to the third, we can change that because it's taken to the 5th power by multiplying these exponents. And when I take 3 times 5x, I'm going to get 15x. It's key that you have that x in there because it was already there. It still needs to be in the exponent. Where this gets a little bit tricky, though, is down in questions 7 and 8, where we need to take those numbers, change the base, and now we have what's called a binomial, or two terms in the exponent. And that makes things a little bit more challenging. So I turn that 4 into a 2 squared. Now, to multiply these exponents, I have to be extremely careful here because it's not just 2 times x and then add 7. What I really have is this, 2 times the quantity, x plus 7. So to find the exponent, I have to distribute the 2 to the x and the 7, which gives me that 2x plus 14. Same thing in number 8, 3 to the third is 27. So when I multiply the exponents, I have 3 times x minus 4, because that's this exponent times this exponent. Distributing gives me 3x minus 12. So again, things to keep in mind that you want to take your time on these because we want to make sure we get the right exponents. Otherwise, later, things are going to kind of fall apart. In activity 2, we're actually putting our skills from activity 1 to use. So looking at number 1, we had 2 to the x times 4 to the x. The directions say rewrite each expression below as a single term exponential expression with base 2. And that right there is really key, that everything in this problem should be base 2, and we want a single expression. So just one base. So in number 1, I cannot change the 2 to the x because it is already base 2. I don't want to do anything with that. But I am going to change the 4 to the x because I have 2 squared. All right, I want to have a base 2. So when I do that, I have 2 squared to the x. And now once we have that base changed, we have to just follow our rules that we've been using. So I'm going to leave this alone for now. And I multiply the 2 and the x together to give me 2x. Once I have this, now the same base, I've taken care of all the multiplication of exponents. Now I'm looking at the multiplication of these bases. I've got a 2 to the x and a 2 to the 2x. I can add the exponents together to give me 3x. Similarly, down here in number 3, 2 to the 3x, and we have 2 to the 4 to the x plus 1. Again, 16 is 2 to the 4th power. We multiply these exponents by distributing the 4, giving us 4x plus 4. Now that it's just a straight multiplication problem, the exponents are added. 3x plus 4x plus 4 gives me 7x plus 4. That's my new exponent. And down on 4, 5, and 6, we have division going on. So let's pick out a good one here. Let's just go with this one here, number 6. So on number 6, I'm going to change 8 to 2 to the third. And now my new exponent is going to get multiplied by x minus 2. In the bottom, I have 4, so I'm going to change it to 2 squared. And again, my exponent is going to be multiplied by x minus 2. So when I do that, let's multiply that here, and multiply that there. These are my new exponents. Now to find my final answer, I'm not going to add the exponents together because I do that with a multiplication problem. But this is division with the same base. So instead of adding the exponents, I'm going to subtract them. So I'm going to take 3x, and I'm just going to kind of line up the like terms. 3x minus 2x is 1x, and negative 6 minus negative 4, that's a plus 4, gives me a negative 2. So my new exponent then is 2 to the x minus 2. It may help you to rewrite it like that when you're actually going through. So we can change some things around a little bit. This is going to become a plus negative 2x and a plus 4. So it might be a little bit easier to see that this would give you a 1x and a negative 2. In the next part of the activity, we're just using base 3. Again, our rules aren't really different, so I want to take a look at number 9 and number 11 because those are kind of unique looks at the problems. So on number 9, we have 27 to the x plus 2 to the second power. And at base 3, I'm going to turn that 27 into 3 to the third. Now, there's a couple approaches we can do. One approach is to multiply 3 times x plus 2 to get the 3x plus 6, and then multiply that by 2. So distributing, we get 6x plus 12. There is another way you could do it. You might actually start off with a 2 and work your way into here. So start off with a 2 and multiply. So we would have 3 to the third, and then that would be times 2x plus 4. Or sorry, 2 to the 2x plus 4. Then you would multiply those exponents, and you would end up getting the same thing. So there's no one right approach. It's just a matter of making sure you're following the correct rules. Number 11, looks like we have some addition going on and some subtraction going on with exponents. So the first thing I'm going to do is put these guys together. So it becomes 3 to the 2x plus 3. And because we're dividing, we're going to subtract the exponent. So it's 3 to the 2x minus 4. The next part of this was just using base 5. So again, same idea. Nothing really different here. It's just a matter of what's your base. Now, I want to look at 18, though, because this is where it's a little bit interesting, is we have actually 3 things going on. We have 3 things being multiplied. So I'm going to change this here, and pardon my chicken scratch, but that's actually a 3, so we're going to rewrite that as 5 to the third. So we have 5 to the third. 25 I'm going to turn to 5 squared. Taking that to the 2x will give me 5 to the 4x. 125 is 5 to the third. Taking that to the x plus 1 is 3x plus 3 for my exponent. Now they all have the same base, and it's all multiplication. So I'm going to add all my exponents. Looking for like terms, I've got a 4x and a 3x, and I have a 3 and a 3. So 4x and 3x is 7x, and 3 and 3 is 6. And that's my new expression. And the last part of the activity, we're looking at what happens when we can't put everything together, when we're going to have something that can't reduce down to base 2. So number 19 is an example of something that it just can't do it. You can't take all 3 of those parts and turn them down to base 2. 3 does not change. The 2, well, it's already base 2. And the 4 we can easily change to base 2 by making it 2 squared. So once again, we want to look at any multiplication of exponents first, and we've got one right here. So we'll make that 2x. Then we can combine these two, highlight those, because they have the same base. So you can add the exponents up to give you 2 to the 3x plus 1. Now the 3, there's nothing we can do with it. It just kind of goes along for the ride. It's a coefficient. That's the part that we're looking for. The coefficient. You can't put it together with the 2. You can't make that into a 6. It just doesn't work. Similarly, in 20, we're going to follow the same rules that we've been doing. Something that you might want to be mindful of is 49 divided by 7 would reduce fairly quickly. So that might be something you don't need to write it in terms of exponential functions. You might not need to write it as 7 squared over 7 or 7 to the first. If you know 49 divided by 7 is 7, go for it. But the 4 to the 2x plus 1 and the 8 to the x minus 1 do have to be changed to base 2 in order for this problem to work out.